All right, so we're now moving on to section C in our chapter 17. And what we're going to talk about here is our axis, so our x and y axis and our intercepts. So we're going to focus on our x-intercept and our y-intercept. So before we get started in talking about this, let's just go ahead and think about this. When we're finding our x-intercept, so that is where our graph crosses our x-axis. Well, what is our value when we're crossing our x? What is our y value when we're crossing our x-axis? As we're moving along our x-axis left or right, our x value will change. However, when we're at this x-axis, we have never gone up or down from the origin. We just went left or right. So when we don't move up or down, that means our y value never changed from the origin. And along our x-intercept, our y value is equal to 0. And then for our y-intercept, that is where we are crossing the y-axis, where our graph crosses the y-axis. And the same thing as what I was just saying about the x-intercept. When we're at our y-axis, our x value from our origin never moved left or right, because here's our origin, and we're just moving up or down. The y value can change on our y-intercept, because that's what we're solving for, but we never have moved left or right. So when we don't move left or right, our x value for all of our y-intercepts are equal to 0. Right? So in the beginning, we're just going to go ahead and find our x and our y-intercepts, and it's really easy. When you're finding your x-intercept, you set y equal to 0. When you're finding your y-intercept, you set x equal to 0. So whatever intercept you're trying to solve for, you are setting the other variable equal to 0 and then solving. All right, so let's go ahead and do a couple examples. All right, so for the y-intercept, as I was saying before, we're going to set our x equal to 0. And when we're solving with our x equal to 0, if you notice, our standard form is ax squared plus bx plus c. So whenever we set x equal to 0, well, 0 squared times 0 is always going to be 0, and anything times 0 is always going to be 0. So whenever we are solving for our y-intercept, it will always be equal to just our constant, because whenever we substitute 0 in for x, we're going to cancel out our ax squared and our bx, because they will be multiplied by 0, and then our answer will just be that constant. So let's just do an example real quick. If I have y is equal to 2x squared minus 3x plus 5, and I ask you to solve for the y-intercept. So since we're solving for the y-intercept, we will say, well, x must be equal to 0. So we know our ordered pair will be 0 comma something. All right, then we substitute in 0. So y is equal to 2 times 0 squared minus 3 times 0 plus 5. So y is then equal to, this will give me 0, 0, so y is then equal to 5. So our y-intercept is 0 comma 5. Right? You will always have one y-intercept. You can never have more than one when you're solving for your graph. All right? You can never have more than one. You can only have one. And this just tells us where our graph is crossing our y-axis. So we have 1, 2, 3, 4, 5. So I know that my graph, whatever it will look like, is going to be crossing here at 0, 5. All right, now let's go ahead and solve for our x-intercept. All right, now for our x-intercept, we are going to set y equal to 0. And as we have talked about plenty of times before in class, we know that our graphs can cross our x-intercept twice, and this means that we have two solutions, or we can have two x-intercepts. Here our graph would cross it once. So here we would have one solution or one x-intercept, and then we can also have none, where we would have no solutions or no real solutions. We'd have two complex solutions, but it would never cross our x-axis, so we would have 0 x-intercepts. So this still works whenever we're solving for our x-intercepts, because you know whenever we are solving for our zeros, we are looking actually when our y value is equal to 0. So whenever we are solving for our equations, we're actually finding our x-intercepts. So in order to solve A, we need to go ahead, whenever we're finding our x-intercepts, we are setting y equal to 0. So for A, it'll be 0 is equal to x squared minus 6x plus 9. Now you can use any of the methods that we've learned to solve. You can factor, you can complete the square, or you can use the quadratic formula. It's your call. When I look at these, I can see, I know that this one factors nice and easy, so I'm going to go ahead and factor it. If you don't know that, we know that quadratic formula works 100% of the time, so maybe that's the one that you would want to use every single time. It's really your call. But if we're going to factor, I'll use the x method. We have 9, and this is -6 because 1 times 9 gives me 9. And numbers that multiply to 9 and add up to 6 are -3 and -3. So this is going to factor out to x minus 3 squared, because I have two of them, is equal to 0. So I can go ahead and take the square root of each side. So x minus 3 is equal to 0. I would add over 3, and we would get that x is equal to 3. So in this case, I only have one x-intercept, and that will be at the point 3, 0. Right? Because when I factored, it gave me the exact same factors, so it could actually look like something like this one over here if this was 3, but facing up because it's positive. But we know that we have our x-intercept of 3, 0. So if I want to solve for b, whenever we're finding the x-intercept, we set y equal to 0. Remember, it's always the opposite. So then we have 0 is equal to negative x squared minus x plus 6. Remember, we always want to have a positive x squared. So I'm going to factor out this negative. So 0 is equal to -1 times x squared plus x minus 6. And then I'm just going to go ahead and divide each side by -1 to clear out that GCF. And since it's set equal to 0, not y, we can do that. So I'll cancel out our -1 here, and 0 divided by anything is 0. So now we get x squared plus x minus 6 is equal to 0. Once again, use any method you want. I know that this one's going to factor nice and easy, so I'm just going to use factoring. If you don't know that and you want to make sure that you're getting the correct answer every single time and not wasting your time, then maybe you jump to quadratic formula. It is your preference, your call. But we know that -6 times 1 will give me -6. 1 drops to the top. Numbers that multiply to -6 and add up to 1 are -2 and 3. We put them over top of 1, so we have x minus 2 times x plus 3 is equal to 0. And then from here, we will solve each one. X minus 2 is equal to 0, or x plus 3 is equal to 0. And when we solve for each one, x is equal to 2, or x is equal to -3. So remember, you can have 2 x-intercepts, you can have 1 like we did in A, or you can have none. In this case, we had 1. And on this one, we have 2 of them. So our answers for our x-intercepts will be 2, 0, and -3, 0, because we have 2 solutions. We have 2 x-intercepts, right? So whenever we are solving for a y-intercept, we set x equal to 0. That one's really easy. It will just be our constant will end up being our y-intercept. Whenever we have x-intercepts, it's a little bit more work, but still easy because we've been doing this for a little bit now. We just set y equal to 0, the opposite variable that we're solving for, and then we just can factor, complete the square, or quadratic formula. Your call. All right, now there's just one more question we're going to go through, which is graphing. That's it for this video. All right, so for the last thing we're going to do is we're going to graph just this function. We're not graphing the other, and this one's just an equation. Remember, if it's a function, it should be written as f of x. But we're going to graph this equation, this function, by using the x and y intercepts. All right, so this one just says sketch, and it doesn't really want you to create a table or to do it precisely. But since we're not graphing that much throughout the year, we are going to make sure that we're graphing exactly like we should be. So we're not going to just sketch this. We're going to create, solve for our x and y intercepts, and then we're going to find our vertex to help us finish off our graph. All right, so the first thing we're going to do is look at the value of a, and that's going to help us determine what's going to happen with this graph. So since the a is positive and 1, the first thing I know is that my graph is going to be facing up because we have a positive a, so I know my graph is facing up. So it's the first thing you should think about. All right, then we're going to go ahead and solve for a y-intercept. When we're solving for a y-intercept, we set x equal to 0. This one's nice and easy. Y is equal to 0 squared minus 2 times 0 minus 3. So y is simply equal to -3, and our point is 0, -3. So I can go ahead and plot that point. Our x is 0, y is -3. 1, 2, 3. So there's our point. All right, then we're going to go ahead and solve for the x-intercept. So to solve for x-intercept, which I'll do over here, we need to go ahead and set our y equal to 0. This one's a little bit trickier, a little bit more work, but we've been doing this enough now that it's really not that difficult. But 0 is equal to x squared minus 2x minus 3. So now you can use any method you want. I know this one's going to factor, so I'm just going to go ahead and factor it. We would have 1 times -3 is -3. The -2 drops to the top. Numbers that multiply to -3 and have a difference of 2 is going to be -3 and 1. We put it over our a, which is 1, so it factors out to x minus 3 times x plus 1. It's equal to 0. We would set each factor equal to 0, so x minus 3 is equal to 0, or x plus 1 is equal to 0. And we solve. X is equal to 3, or x is equal to -1. So we have 2 x-intercepts at 3, 0, and at negative 1, 0. So I can go ahead and plot those points. So at 3, 0, 1, 2, 3, and at negative 1, 0. All right, now the last thing that this book doesn't ask for you to do, but what I want you to do is because if we're just sketching this, we haven't learned yet how to find our vertex using any other method. So once we get to our next section, you can use a different method to go ahead and do this next part, but I'm going to want you to rewrite this into vertex form so that way we know where a vertex is and we're graphing a more accurate graph. So y is equal to x squared minus 2x minus 3. We've already done this. We're going to go ahead and complete the square. So y is equal to x squared minus 2x, leave space, minus 3. So then we take our 2, we divide it by 2, that's 1. We square it, that's equal to 1. So then we will add it inside of our parentheses always. And then since we're adding 1, we need to offset it. So we subtract 1. And this will then factor out to y is equal to x minus 1 squared minus 4. We've already done this in our last sections. We've already tested on this now. So I have faith that we could go through this kind of quickly. And now we look. This is telling us we're moving 1 to the right and down 4. So that means our vertex is at 1, negative 4. So I can plot that point. We're at 1, 1, 2, 3, 4. And something else we're going to talk about in our next section, but since we know our graphs, we've already talked about this briefly, but our graphs are symmetrical about our vertex, and we've already talked about this a little bit, and we're going to get into more detail in our very next section. But since we know it's symmetrical, I know that I'm going to also have a point right here 1 unit away. And that will then give me my graph. All right, so there's our parabola and there's our graph. So although the book is asking you to just quickly sketch it, I do want you to find your vertex. And you can then use your x and y intercepts to help you finish graphing this off. All right, that is it for this video, and that is it for this section.